Good morning, everyone. My name is Zoi Skaperda, and I'm a PhD student at the Department of Biochemistry Biotechnology and the laboratory of Professor Paredes. I will present you the effects of little liquids of electronic cigarettes on the redox status of endothelial cells. As we know, Greece is on top of the list of the European countries regarding smoking. That means almost 4 out of 10 Greeks are regular smokers. As you can see in the diagram, most popular flavors of e-liquids include fruit, tobacco, menthol, and candy flavors. E-cigarettes seem to contain less toxic chemicals and have lower emission levels of hazardous substances than cigarette smoke. Electronic cigarettes do not burn or use tobacco leaves, but instead vaporize a solution that the user then can inhale. Regarding the liquid components, we have different PCVG ratios and they have different effects on cloud production and throat heat. Specifically, the liquid samples that we used in our study are 3 tobacco-flavored e-liquids with 50-50 ratio of PGVG and nicotine concentrations equal to 0, 12, and 18 mg per ml. There are also 2 apple mint flavor e-liquids with 70-30 ratio of PGVG and nicotine concentrations equal to 12, 18, and there are also 2 vanilla flavored e-liquids with 70-30 ratio of PGVG and nicotine concentrations equal to 6 and 12 mg per ml. Free radicals are any chemical species capable of independent existence and containing one or more unpaired electron. Oxygen-centered radicals are called reactive oxygen species. A dioxidant is named any substance that, when present at low concentrations compared with that of an oxidizable substrate, significantly delays or inhibits oxidation of that substrate. Regarding the dioxin defense mechanism, they are separated into categories: the enzymatic, with superoxide dismutase catalase and other enzymes, and the non-enzymatic, such as glutathione, retinol, vitamin E, and more other. Oxidative stress is called a disturbance in the peroxidant-antioxidant balance in favor of the former. It has been related to a plethora of diseases including cardiovascular diseases, pulmonary disorders, neurodegenerative diseases, diabetes, and several types of cancer, aging, and other more diseases. The aim of our study was to investigate the effects of 3 different electronic cigarettes or fill liquids on the redox state of human vascular endothelial cells. For this purpose, the AHI-926 cell line, a hybrid cell line derived from the human umbilical vein endothelial cells and epithelial cells from human lung carcinoma, was captured. Now we can begin with our results on the ketotoxic effects of liquids. Specifically, all 3 tobacco-flavored e-liquids and peppermint flavored e-liquids with nicotine levels equal to 0, 12, 18 mg per ml exerted ketotoxic effect at 2.5% and higher concentrations than that. The 2 vanilla flavored e-liquids with nicotine levels at 6 and 12 mg per ml showed ketotoxic effects at concentrations equal to 5% and concentrations higher than this. So, based on these previous results, we selected the e-liquids concentrations and we selected the concentrations that have the lowest ketotoxicity, as you can see in the table. Regarding our results in the GSH and ROS levels, as you can see, the vanilla flavored sample with nicotine concentration equal to 12 mg per ml increased GSH levels of the cells by 110% of the ketotoxic concentration compared to the control. The peppermint flavored sample with nicotine concentration equal to 12 mg per ml increased the GSH levels by 107% at the ketotoxic concentration. As regards the ROS levels, the tobacco-flavored sample with nicotine concentration equal to 0, 12, 18 milligram per ml, and the vanilla flavored sample with nicotine concentration 6 milligram per ml increased gross levels of the ketotoxic concentration by 59, 57, 54, and 40% respectively compared to the control. In contrast, the April mint flavored sample with nicotine concentration equal to 12 milligram per ml decreased gross levels at the ketotoxic concentration by 44% compared to the control. As for the TAC biomarker, as it is shown in figure, no statistically significant alterations in TAC levels were observed after incubation of the cells with the e-liquid samples. Regarding the effects of the e-liquid samples on protein carbonates, the vanilla-flavored sample with nicotine concentration of 12 mg per ml decreased protein carbonates levels at the ketotoxic concentration by 41% compared to the control. The 18 mg per ml apple mint flavored sample decreased protein carbonates levels at the ketotoxic concentration by 32% compared to the control. As for the levels on the lipid peroxidation, the tobacco-flavored samples with nicotine concentrations equal to 0, 12, and 18 mg per ml increased TBARS levels at ketotoxic concentration by 40, 38, and 53% respectively compared to the control. The vanilla-flavored sample with nicotine concentrations equal to 12 mg per ml increased TBARS levels at the ketotoxic concentration by 71% compared to the control. Finally, the 12 mg per ml apple mint flavored sample decreased lipid peroxidation at the ketotoxic concentrations by 22% compared to the control. In summary, the pattern of the effects on the 5 redox biomarkers is different among e-liquids. Tobacco-flavored e-liquid promotes reactive oxygen species generation and lipid peroxidation. As for the apple mint flavored e-liquid, it enhances GSH production, which can lead to decreased ROS levels and protects against lipid and protein oxidation. The vanilla-flavored e-liquid, a different effect was observed as it increased GSH, ROS, and TBARS levels while protected from protein oxidation. The present study examined the role of three-flavored electronic cigarette refill liquids on the redox state of human endothelial cells. Regarding the ketotoxicity of the e-liquids on the AHI cell line, we have observed a dose-dependent action since increasing e-liquid concentrations led to decreased cell viability. Specifically, we report that tobacco-flavored and apple mint-flavored e-liquids started exhibiting ketotoxic action at the concentration of 2.5%, while vanilla-flavored e-liquid started inhibiting cell viability at the concentration of 5%, indicating that tobacco-flavored and apple mint-flavored liquids elicit more toxic effects on the endothelial cells. The present study aspires to shed light on how three specific flavored liquids interact with endothelial cells by affecting their redox status. At present, there is limited literature evidence regarding the effects of the liquids on the redox status of endothelial cells. We report herein that the role of three specific liquids, the tobacco, the vanilla, and the apple mint flavor, their effects on cell redox status depends highly on their flavor and therefore their chemical composition and not their nicotine content. The overall toxicity resulting from the use of e-liquids in electronic cigarettes is a multifactorial phenomenon in which many variables are involved, and therefore this study may at present merely give indications about the effect of three specific flavored e-liquids on the redox state of endothelial cells. It is therefore necessary to further research on this subject to elucidate the mechanism governing the toxicological effects of refill liquids. I want to thank you very much for your attention. Bye.